Okay, let's take a look at the Chapter 11 review for Advanced Algebra 2. Hopefully this will help some of you who are struggling a little bit with how to do some of these types of problems. If we look at the first one, that's a system of equations. Sketching the graph helps you understand the solution that you get algebraically and helps you actually understand if you have an extraneous solution. So if we look at the first one, x squared minus y equals 1. If we have x squared plus 1 equals y, that's the equation of a parabola shifted up 1 unit, standard width, and so that looks approximately like that. Second, I have the equation of a circle, the x squared plus y plus 3 squared equals 16. So I have a circle with a center at 0, -3, and a radius of 4. So at 0, -3, and it has a radius of 4, so I can just go 4 units in any direction in all those directions, and then I can kind of sketch in that circle. So by graphing this parabola and this circle, looks like I have one solution. It looks like that solution is at 0, 1. But you still need to work on it algebraically. To do that, I would take the first equation, x squared minus y equals -1, and I would add the y to both sides. So x squared is equal to y minus 1. Then you can substitute y minus 1 into the second equation for x squared. So that becomes y minus 1 plus, then FOIL that y plus 3 squared, so you'll get y squared plus 6y plus 9 equals 16. Combine like terms, and you should have y squared plus 7y plus 8 equals 16. And then solve that by subtracting the 16 from both sides. And now you can factor that y squared plus 7y minus 16. That factors to y plus 8. Sorry, that's not 16, that's an 8 right there. And y minus 1 then. So I get two solutions for y. Y is equal to -8 and 1. When you substitute that back in to this equation, x squared minus y equals -1, I have x squared minus -8 equals -1, x squared plus 8 equals -1. So x squared equals -9. Can't take the square root of a negative number, so therefore that value y equals -8 is an extraneous solution and does not work. So then check the other, x squared minus 1 equals -1, so x squared equals 0, so x equals 0. So I get the solution that I see graphically at 0, 1, and that's the only solution to this system. The next one is just a little bit harder to graph. It's not pretty. If you look at that, you have an ellipse and then you have a circle. We'll start with the circle because that's easier. Its center is 0, 0. Its radius is 5. So that's about what the circle looks like. It could look a little bit rounder. Now let's take a look at what that ellipse looks like. And for the ellipse, when you solve this, you should get something like x squared over 867 plus y squared over 61.67 equals 1. That gives me an A of about 7.9 and a B of about, I have 2.9, but that can't be. Just 1 second. Yes, a B of about 2.9. Remember, when the largest value, A, is under the Y, that means its orientation is that its principal axis is parallel to the Y-axis. So now I know I have vertices at 0, the Y-axis 0, and then I'm going to go up 7.9 and down 7.9. So I have a vertex here at 0, 7.9, and another one at minus 7.9. Then I have endpoints at negative 2.9, 0, and at 2.9, 0. So my ellipse and my circle intersect in that manner. But now I need to find algebraically the points of intersection. The easiest way to do that algebraically is to say take the second equation and multiply by a negative 9. So the first equation I'm going to leave alone, 6x squared plus 9y squared equals 555. The second one I'm multiplying by negative 9, giving me a negative 9x squared minus 9y squared equals negative 225. I'm using the elimination method. Now when I add these together, I will get 55x squared, the y's cancel, equals 330. So x squared is equal to 6, so x is equal to plus or minus the square root of 6. So it looks like I have 4 solutions, so I'm going to use both positive and negative root 6 to verify these solutions. So I have x squared plus y squared equals 25. When I substitute in the square root of 6, I get 6 plus y squared equals 25. So y squared equals 19. So y equals plus or minus the square root of 19. And of course, if I substituted in a negative square root of 6, I would get the same answer because when I square that negative, it becomes positive. So that means I have the following solutions: the square root of 6 and the square root of 19, which would be here. Then negative, nope, sorry, that's positive square root of 6 on this side. Square root of 6 and negative square root of 19 here. On this side, I have negative the square root of 6 and the square root of 19. And then here, I have negative square root of 6, negative square root of 19. So these 4 solutions are the answers to this particular system of equations. So tomorrow on the test, you'll be asked to sketch the graph, and that's to help you understand how many solutions it has and if it has any extraneous solutions like the previous example. You don't have to be terribly accurate with all the points, just try to get them close so that you can verify your algebraic work with your graph. Okay, number 3 says, given the following equation, determine the values of A and B and write the equation of the asymptotes. So you're going to divide all 3 terms by 64, and then you know it's a hyperbola, it has asymptotes. So that means my equation is x minus 2 squared over 4 minus y plus 1 squared over 16 equals 1. So to get an idea of what this looks like, you can put it on the graph. Its center is at 2 minus 1. The value of A is the square root of 4, which is 2. The value of B is the square root of 16, which is 4. So that means it's going to have a vertex 2 units to the right. So that's going to be at 4 minus 1, and then at 0 minus 1. And that's what it would look like. You don't need to sketch that, but sometimes it's useful. So now I have my values of A and B, and this opens left and right, which tells me that the slope is going to be equal to plus or minus B over A. You'll use slope-intercept form. Y minus y1 is equal to m times x minus x1 to find the equations of the asymptotes. So I have y plus 1 is equal to the slope 4 over 2, which is just going to be 2, times x minus 2. And this is plus or minus. So one equation, y plus 1 is equal to 2 times x minus 2. The other, y plus 1 is equal to negative 2 x minus 2. So y plus 1 equals 2x minus 4. So y is equal to 2x minus 5 is one of the equations. And please finish these. Don't leave it in this form. Please finish it. Y plus 1 is equal to negative 2x plus 4. So y is equal to negative 2x plus 3. And that is the other equation of the asymptotes for that hyperbola. Number 4 asks you to find the center and the radius. Find the center and the radius. So on this one, we'll need to complete the square. It's a circle if you're asked for the center and the radius. I have x squared plus 6x, I'll leave a little space, plus then y squared minus 8y, add the 39 to the right-hand side. Complete the square on the x's, means I'm going to take 6 divided by 2 and square that. That's 9. I'll add 9 to both sides. Then I will take 8, divide that by 2 on the y, and then square that, and I will add 16 to both sides. Take the perfect square trinomials and write them as binomials squared. 8 plus 3 squared plus y minus 4 squared equals 64. So your center is at minus 3, 4, and your radius is 8. Number 5 says write the equation of an ellipse whose major axis ends at 4, 8, and negative 6, 8. So plot those. So here is 4, 8, and negative 6, 8, and whose minor axis is at minus 1, 4, and minus 1, 12. So if you just draw those two axes in, you'll find the point of intersection, which is the center. Remember, the center is going to be the midpoint of the major axis and the minor axis. So that's going to put my center for this problem at minus 1, 8. And I'm asked to write the equation. So I know the length of this major axis is 2a, and that is from -6 to 4, that is 10. So 2a is equal to 10, therefore a is equal to 5. And then the length of the minor axis, which in this case is 8, that's 2b, so b is equal to 4. So now I have the center, I have the length of the major axis, I have the length of the minor axis, and I can see that the major axis is parallel to the x-axis. So that means the longest length is under the x squared. So the equation for this ellipse would be x plus 1 squared over 25 plus y minus 8 squared over 16 equals 1. Okay, number 6, write in standard form the equation of the ellipse whose endpoints, now I'm given endpoints, and the sum of the focal radii. Remember, the sum of the focal radii is 2a. 2a is the distance between the two vertices. So now let's plot the endpoints, -3, 4, and -3, -4. So this length is the length of the minor axis. I know my center happens at the midpoint, so the midpoint is going to be at -3, 0. So this is the center. If the sum of the focal radii is 12, 2a is equal to 12, so therefore a is equal to 6. Go to the center and go 6 units right and 6 units left. And you'll have a vertex here at 3, 0, and another at -6, 0. Not -6, sorry, going 6 units. That's going to put me at -9 over here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, that one must be the 10. Okay, so now I know that B is equal to 4 units. So I have the center, I have the length of B, and I have the length of A. So I have x plus 3 squared over, remember its principal axis is parallel to the x-axis. That means the larger value is under the x squared. That's going to be 36 plus y squared over b squared, which is 16, equals 1. Number 7, write the equation given the absolute value of the differences from -5, 2 to 5, 2 is 6. Okay, that means that these are both foci, and 6 is the length of the transverse axis. Or 2a is equal to 6, therefore a is equal to 3. Again, find the midpoint of the two foci, and that's going to be at 0, 2. So the center is at 0, 2. The length 2a from the center to a vertex, so you have a vertex at 3, 2 and -3, 2. Looks like this. those arms of the hyperbola wrap around the foci. The distance C, so 2C, is equal to the length of the axis that connects those two foci, and that's going to be 10, so C is equal to 5. The relationship in hyperbola is a squared plus b squared equals c squared. Therefore, b is equal to 4. And that would be that picture. So now you just have to write the equation. The center is at 0, 2. So I have x squared. It's opening left and right, which means the minus sign is on the y squared. A is 9 minus y minus 2 squared over 16 equals 1. Okay, next one is a delightful little parabola. It says find the equation of the parabola with a directrix at y equals minus 4. 1, 2, 3, 4, right here. A focus at 5, 0. Okay, so the distance from the focus to the directrix is 2p. The vertex is the midpoint. The midpoint is going to be at 5 minus 2. So therefore, p is equal to 2. Remember, a is equal to 1 over 4p. Therefore, a is equal to 1 over 8. Given the orientation, the parabola opens up. So now, standard form of the equation is y is equal to x, or a times x minus h squared plus k. So y is equal to 1/8 x minus 5 squared minus 2. And that's the equation of the parabola given that information. Number 9, a rectangular garden is surrounded by 80 feet of fencing. The area of the garden is 375 feet squared. What are the dimensions of the garden? So I have a garden, length times width. The area of the perimeter is 80 plus 2L, or excuse me, 80 equals 2L plus 2W. Which means 40 is equal to L plus W. Then, so I'll have that actually as 40 minus W equals L. Then I have the area. The area is equal to length times width. The area is 375. That's equal to the length, 40 minus W, times the width, which is W. So I get 375 is equal to 40W minus W squared. Add the W squared to both sides, and then subtract the 40W from both sides. And then see if that is factorable. And it is. W minus 15 times W minus 25 is equal to 0. So W is equal to either, actually W is equal to either 15 or 25. So those are the dimensions of the garden. Length times width, or length plus width, width can be 15, and then length would be 25, or the other way around. Okay, determine the locus of all points equal distance from 2 points. The locus, remember, the locus of all points equal distance from 2 points is a perpendicular bisector. So you have at -3, 9, and 5, 4. A line segment. First thing you have to do is find the midpoint of IS. So -3 plus 5 over 2 and 9 minus 4 over 2 is going to give me a midpoint of 1 and 5/2. Then you need the slope of IS, and that's going to be equal to 9 plus 4 over -3 minus 5. So 13 over -8 is the slope of IS. Therefore, the perpendicular slope is equal to 8 over 13. So now you have the midpoint at 1 and 5/2, and then you have the slope of that line. So you can use slope-intercept or point slope. Y minus y1 is equal to m times x minus x1. Substitute the ordered pair, the midpoint, in as x1 and y1. So I have y minus 5/2 is equal to 8/13 x minus 1. So that gives me y minus 5/2 is equal to 8/13 x minus 8/13. And I'm going to add 5/2 to both sides. So that's going to give me this y is equal to 8/13 x minus 8/13 plus 5/2. Please don't leave your equation like that. You should be able to simplify those real numbers. So that's going to give me y is equal to 8/13 x minus 8 over 13. Then 5/2 is going to become, let's see, in order to get 13 in the denominator, going to have to multiply 8/13 by 2. And that will give me 16 over 26. And then 5/2 I'll multiply by 13, and that will give me 65 over 26. So y is equal to 8 over 13x. And then when I add minus 16 over 26 plus 65 over 26, I should get 49 over 26. And that's the equation of that perpendicular bisector for that segment IS. Okay, last one. Determine the locus of points equal distance from the 3 points. And those 3 points are 0, -2, and that's A, 9, 7, that's B, and then -1, 7, that's C. Okay, and you can check and see if that's a right angle. I don't believe it is. So you're looking for the point that is this point xy that is equal distance from A, B, and C. We're going to label this D. So remember, I have the length AD is the square root from that center xy to A. So that's going to give me x squared plus y plus 2 squared. The distance, from B to D, so BD is the square root of x minus 9 squared plus y minus 7 squared. And finally, CD, which is the length x plus 1 squared plus y minus 7 squared. So I'm looking at this length, AD, BD, and CD. Now I have to set two of those equal to each other. You can skip a few steps at this point. I want to set BD and CD equal to each other. I know I'm going to square both sides, so I'm just going to skip that step. X minus 9 squared plus y minus 7 squared is equal to x plus 1 squared plus y minus 7 squared. And I chose BD and CD because I noticed that they share that y minus 7 squared. So now, when I subtract that y minus 7 squared from both sides, I'm just left with x's, and I have x minus 9 squared is equal to x plus 1 squared. Now I only have one variable, and I can solve that pretty easily. FOIL both of those, so x squared minus 18x plus 81 is equal to x squared plus 2x plus 1. Subtract the x squareds from both sides. Subtract the 2x from both sides. Subtract the 81 from both sides. So you're going to have negative 20x is equal to negative 80. So x is equal to 4. Once you find the value of x, pick a different combination of those three equations. I would pick AD equal to CD. This time, substitute in that value that you have for x. So now, AD, my value of x is 4, so that gives me 16 plus y plus 2 squared is equal to, then CD, I have 4 plus 1 is 5, so that gives me 25 plus y minus 7 squared. Go ahead and FOIL those then. I'm going to put a line there. 16 plus y squared plus 2y plus 4 is equal to 25 plus y squared minus 14y plus 49. Combine like terms, so y squared plus 2y plus 20 equals y squared minus 14y plus 74. Now solve that for y, subtract y squared from both sides. Let's see, add 14y to both sides, and then subtract 20 from both sides. The y squareds will cancel. I'll have 16y here. Oh, sorry, I made a mistake. This is a 4y back here, so this is a 4y. So this should be 18. And that 18y is equal to 54, so y is equal to 3. So that ordered pair, this point D, is at 4, 3. Okay, I think that's the end of the review worksheet. Hopefully that was helpful. Remember, your Chapter 11 test is tomorrow. Have a good evening, and I'll see you tomorrow.